Um, Hello there. This is Charon Paul Puig, student number 100-656-910, and I'm going to be explaining the lights and color collection, or I guess mainly the LUTs, for this activity with Sue. So first of all, I'm going to be showing the lights example for this. So as you can see, yeah. So first of all, I'm going to show you examples of each of the certain lights in this assignment. So number one, first one is ambient light, or ambient light basically is a light that is not a complete light. But rather it simply adds RGB as a final result. So like it's dark but never completely dark, and gives the object some color. In this case, I'm not really sending much of a color except that it becomes more white as it's close to the light. Um, Number two, the next one is diffuse light. This one has the texture in it, and as you can see, first of all, diffuse light simulates the directional impact that a light object has on, like a light source has on an object, and it's calculated by how light reflects off a surface. And basically, diffuse lighting gives the object more brightness the closer it is to the light source. As you can see in this example, that it becomes more bright and clear to see as it gets closer to the light in the middle. And yeah, the more light the object faces, the brighter it gets. The next one is specular. Zoom in here. Specular simulates the bright spot of an object that appears on like shiny objects. So you can see here in the monkey, since there was light here, as I move it from left to right, as you notice, the specular changes based on the direction. So specular lighting basically is based on the light's direction vector and the object's normal vectors, but this time it's also based on the view direction. So yeah, let's see, changes based on the direction. See the amount of specular as rotate through it. In this example, and based on the reflective properties of light.
Hi, I'm Inshu Wang. My student ID number is 1006-14552. And what I am gonna talk about, and my group members, we will talk about the graphic pipeline, because we use pipeline, and the diffuse, specular, and ambient, and other stuff. First, I'm gonna talk about blur. Actually, how the blur work is we take color buffer texture and extract all the fragments in like certain RGB, and it gives the image that the region is intensities exist in certain area. So actually we take the brighter texture and we blur the result. The filter we use is not that gives that strength of the blur, but if you determine largely, you'll get the harder strength of the blur it can shows up.
Okay, so I'm going to be explaining LUTs now. So here, I'll just share an example of LUTs. This is cool LUT. No, it's the warm, the cool, and then the custom that I just made up. Okay, so sure. Anyways, so basically, how LUTs is being used is that it's being read from the file that's been made ever since I edited the picture and put a filter on top of it. So all of that is being read in this is being read and then sent into a vector called, I guess this is for the cool, and take care of that. And then after that, it's being sent over to the useLut function as for the texture, and then depending on what mode I select, it is whatever depending on where the data was read and sent to, that data is being used depending on the mode. Mainly, it's being sent as a texture.